In this lesson, we'll be learning how to name alkanes. Alkanes are saturated hydrocarbons with a general molecular formula of CnH2n plus 2. In alkanes, all the carbon atoms are linked by single bonds. An alkane with one carbon is methane, 2 carbon, ethane, 3 carbon, propane, 4 carbon, butane, and so on. For the purpose of this lesson, we'll be highlighting 3 steps on how to name alkanes. Step 1. Identify the longest continuous carbon chain, which would be the parent chain. What do we mean by the parent chain? Imagine you have a very big tree with many branches. The trunk of the tree is like the parent chain. The parent chain is the longest main part of a molecule, just like a backbone. Other branches or groups attach to these main chains. Step 2. Number the parent chain from one end to the other, starting from the end that would give the substituent the lowest possible number. That is, we number from right to left and then from left to right. Then we choose which numbering will give the substituent the lowest possible number. Here is something to note. Always write substituents alphabetically. For example, say we have 2 substituents, an ethyl and a methyl. Alphabetically, E comes before M, so we write ethyl before methyl, irrespective of the number attached to this substituent. Another scenario, say we have ethyl and dimethyl. We write ethyl first before dimethyl. This is because we write substituents alphabetically irrespective of the prefix attached to these substituents. Step 3. Combine the substituent name with their location and the parent chain name to give the IUPAC name. So let's take this example. The first thing we need to do is to identify the longest continuous carbon chain. Here are ways we could have numbered this structure. We have 1, 2, 3, 4, 5. Then we have 1, 2, 3, 4, 5, 6. So we have a 5 carbon chain and a 6 carbon chain. 6 is greater than 5, so the longest continuous carbon chain is 6. The prefix for 6 is X. Since this is an alkane, it is hexane. So the parent chain name is hexane. So next, we number the parent chain name from the left to the right and from the right to the left. Then we choose which numbering gives the substituent the lowest possible number. So the first structure here, our numbering was from the left to the right. For the second structure, the numbering was from the right to the left. For our first structure, we have our substituents on carbon 2 and carbon 4. For the second structure, we have our substituents on carbon 3 and carbon 5. 2 and 4 is lesser than 3 and 5. So this first structure will give our substituent the lowest possible number. So the first structure is correct, while the second structure is wrong. So now that we have identified the best way to number this, we combine the substituent name with their location and the parent chain name to give the IUPAC name. So we have chlorine on carbon 2 and we have a methyl group on carbon 4. So this will be 2-chloro, not 2-chlorine. When the substituent is chlorine, we call it chloro. When it is bromine, we call it bromo. When it is fluorine, we call it fluoro. When it is iodine, we call it iodo. So this is 2-chloro-4-methyl-hexane. 2-chloro-4-methyl-hexane. Before we continue, if you find this lesson interesting, why not hit the subscribe button and turn on the notification button so whenever we drop a new video, you get notified. Now, let's take this example. The first thing we have to do is to identify the longest continuous carbon chain. And in this case, we have 1, 2, 3, 4, 5, 6. So the longest continuous carbon chain is 6, which is hexane. So the next thing to do is to number the parent chain from the left to the right and then from the right to the left. For the first structure here, we have an ethyl group on carbon 3 and 2 methyl group on carbon 4. For the second structure, we have an ethyl group on carbon 4 and 2 methyl group on carbon 3. Now, which numbering do you think will give us a lower number for the substituent? Looking at the first structure, we have 3, 4, 4. If we add that together, we have 11. The second structure, we have 4, 3, 3. If we add that together, we have 10. 10 is lesser than 11, so the second structure will give us a lower number for the substituent. So the second structure is correct, while the first is wrong. Now, let's write the name of that structure. We have an ethyl group on carbon 4 and 2 methyl group on carbon 3. Remember, we write substituents alphabetically, so we write ethyl before methyl. So this will be 4-ethyl 3,3-dimethylhexane. 4-ethyl 3,3-dimethylhexane. When writing the name of any organic compound, always use a dash to separate a number from a letter and a comma to separate a number from another number. Okay, try this problem and drop the answer in the comment section. Also, don't forget to subscribe.